The blue marble that we call home is a temporary mechanical state. Long before it was a sanctuary, Earth was a high-energy furnace shaped by the violent physics of a young solar system. For its first 500 million years, Earth existed in the Hadean eon. During this period, surface temperatures were so extreme that the entire planet remained a sea of molten rock, far too hot for the chemical precursors of life to even form. Our planet's structure was largely defined by a massive impact with a Mars-sized object called Theia. The collision was powerful enough to vaporize Earth's outer layers and eject a massive ring of superheated debris into orbit. Under the influence of its own gravity, this ejected material condensed into a single sphere over the course of several weeks, forming the Moon. As the kinetic energy from these early collisions dissipated, the planet finally began to cool. This drop in temperature allowed the surface magma to solidify, forming the first hardened crust. While the young planet cooled, it was continuously bombarded by icy comets and meteorites from the outer solar system. This relentless barrage delivered the water vapor and ice that would eventually condense to form the first liquid oceans. The shift from a toxic firestorm to a water-rich world was the product of a chaotic, specific foundation. These early events created a rare, temporary environment where biology could eventually emerge. Maintaining our current climate requires a precise mechanical equilibrium, driven by the planet's internal heat. This equilibrium is managed by the carbonate-silicate cycle, a process that functions as Earth's primary geological thermostat. This thermostat starts when volcanoes release carbon dioxide, which binds with rainwater. It washes into the oceans, becoming trapped in sedimentary rock. Through subduction, shifting tectonic plates drag this carbon-rich rock into the mantle, melting and venting it back out to keep Earth from freezing. This entire tectonic engine is physically dependent on the presence of liquid oceans. Liquid water acts as a lubricant for the lithosphere. It allows the massive continental and oceanic plates to slide and dive past one another without seizing up from friction. This loop, where water enables tectonics and tectonics regulate carbon, is a primary reason Earth has maintained a stable enough temperature for life to persist for billions of years. Most of us assume Earth will remain habitable until the Sun dies in 5 billion years, but the window for life is closing much sooner. The limiting factor is solar luminosity, the total energy the Sun emits. As our star ages and burns through its hydrogen, its energy output naturally increases. This graph tracks that increase. Every billion years, the Sun grows 10% brighter. Within 1 billion years, this extra energy pushes Earth past its thermal tolerance. The heat breaks the carbonate-silicate thermostat. The planet enters a runaway greenhouse effect, climbing uncontrollably. At this point, the oceans will begin to evaporate. The atmosphere will become saturated with water vapor, which will migrate into the upper stratosphere. In the upper atmosphere, solar radiation will trigger photolysis, physically breaking the water molecules apart. The resulting hydrogen is light enough to escape Earth's gravity, effectively venting the world's water supply into the vacuum of space. Eventually, the increasing energy from the Sun will overpower the planet's internal cooling systems, leaving Earth unable to regulate its own heat. Once the liquid water is gone, the lubricant for the crust disappears. Plate tectonics will seize up, ending all major geological recycling. The result is a sterile, baked desert. The oceans will be replaced by massive salt flats, and the continents will turn to scorched black rock, creating conditions more extreme than those on modern-day Venus. Several billion years after the biosphere has vanished, the Sun will enter its final stage, the red giant phase. As the star expands, it will consume the inner planets. From the surface of a now molten Earth, the Sun will grow until it fills the entire sky. As the Earth's orbit decays, it will be subjected to extreme tidal forces, the gravitational pull that stretches and deforms a planet as it draws closer to a larger mass. These forces will physically tear the planet apart, dragging its fragments into the outer layers of the Sun. Earth was a fleeting anomaly. The same mechanical processes that allowed life to thrive have their limits, and in the end, the window for life has closed.